All right, well, welcome everyone to Energy Star and HVAC grading. Before we get started, we always want to do a member spotlight. Congratulations to our members. EcoAchiever, they provide LEED, Green Rater, and energy rating services on Jefferson Park Apartments, which recently just won the LEED for Homes 2023 awards for outstanding affordable housing development. You can learn more about these on the LEED for Homes awards. And we would wish you would consider hiring EcoAchievers for your next green building project to ensure that it is built better. You know, ultimately, this is who GreenHome Institute members are. This is what GreenHome Institute members do. And so can you. Check out our membership, support our work, and help keep these sessions going. Also, before we start today, a huge thanks to our top tier sponsor, Mitsubishi. If you didn't realize it, Consumers Reports recently put out data showing that the most reliable central air conditioning system isn't even an air conditioning system, it's a heat pump. And so check that out, how Mitsubishi has been the top, as well as other heat pump brands, top system. We need to transform all of our air conditioning systems into heat pump technology. I've done it myself. This pulls in heat, or it works like a traditional air conditioning system, super energy efficiently, but then also in reverse in the wintertime, especially cold weather climate ones like Mitsubishi's systems, Hyperheat, working to energy efficiently and all electrically heat, which can only be powered by renewable resources. And now systems can essentially just be swapped right out, air conditionings, for heat pumps. And this is called dual fuel systems, which can take the place of the air conditioning system and work through Mitsubishi's IntelliHeat program with the existing gas furnace, so that when it's very cold, the gas can still kick on and help. What I also really like is Mitsubishi is putting out resources on how to pair their indoor and outdoor to get compliance with Inflation Reduction Act tax credits. If you don't want to do a ducted system, ductless systems are the most energy efficient systems out there. So you have your traditional mini splits as well as your hidden systems that can be hidden behind walls, or ducted mini splits, which may be the best of both worlds. Learn more at MitsubishiComfort.com. All right, well, welcome everyone again to Energy Star HVAC grading. This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. I am one among our small team of three, Brett Little, the education manager here at the GreenHome Institute. As always, this, like all of our courses, approved for multiple continuing education units, including our Certified Green Home Professional Designation, Energy and Health Pillar. AIA Health, Welfare, and Safety may make it applicable to your state-based design contractor license. And then also check out the Passive House Code for your Certified Passive House Consultant designation. Now, before we get started, because this course is approved for AP Homes designations, it's important to remember how the topics are going to fit within the context of LEED certification and other green building certifications. First of all, we have the LEED Energy and Atmosphere Minimum Energy Performance, and this includes many different applications around energy conservation, but HVAC and HVAC design and installation quality, which we're talking about today, play a huge role in this. So while it's important to know Energy Star is not required for certification under LEED, you are required to basically do everything stopping just short of certification. Might as well get certified anyway, and there are many benefits we'll talk about. But until then, we know we have to achieve the improved HERS index rating, which is what we're going to talk about here today, as well as there's some other applications such as raters needing to check if duct runs are fully ducted, not showing up exactly in what we're talking about today, but another component of the proper HVAC system being designed and installed and tested to comply with the minimum energy performance standards of LEED, ultimately connected to Energy Star. Now, where the real excitement comes into play is when we go through what we're going to talk about today, the grading of the systems. You're going to have an improved energy rating system through your energy rating index or equivalent HERS of that. And so if you look at the Lead for Homes annual energy use program, you will see you can score many energy points by the bulk of your energy points by reducing your equivalent energy rating point thresholds. And so you can just see a snapshot of how this works. HERS 70 starts with 5 points, 69 with 6 points. So again, by having that HVAC graded system, which we're going to talk about today, you can potentially reduce these points even more, scoring more in your LEED application and other green building application. Another important place where this comes in is the LEED Addenda 10431. And in this case, you're talking about achieving a Zero Energy Ready certification, which in order to achieve Zero Energy Ready certification, you have to reduce your energy rating points, ERI, HERS, whatever that may be. And so that's one component. And so by achieving this Zero Energy Ready certification, you are automatically achieving multiple points within the LEED certification program, not just in energy, but in health and other areas. And now under the Inflation Reduction Act, we're going to talk about there are multiple potential incentives, tax credit incentives you can achieve with your projects by doing this. So it's a win-win-win all around. More LEED points, reduced energy points, tax credit incentives, and a better HVAC system. So with that, I am super excited to have back on the show today Dean Gamble. I think, Dean, this is maybe second, third, maybe fourth time at least presenting with a GHI webinar. So it's always good to have.
Definitely some familiar names here and some new names and new locations. So thanks for joining me today. I'm actually going to maybe turn my camera off and share my screen so you can look at the content instead of my face. So again, my name is Dean Gamble. I'm the technical manager for the Energy Star Single Family New Homes Program at EPA. I'm presenting here in Washington, D.C., and I'm super excited to be talking about HVAC and HVAC grading and how it fits into the Energy Star program. I like talking about HVAC a lot, and so this is a topic that's near and dear to my heart. Let's go ahead and get started. I'll turn off my video here. And I want to start with a little bit of context, actually. So maybe some of you on the phone already know this, but installation defects in HVAC systems are actually quite commonplace. That might be news to some of you, but researchers have been demonstrating this for a long time. Studies have shown that there's improper airflow in nearly 50% of systems and incorrect refrigerant charge in 60 to 80% of systems. These are really shocking statistics. So unfortunately, you can't take proper HVAC installation for granted and assume that everything is okay. You actually need to check. Now, why should we care if airflow and charge are right in the first place? Well, the first reason is that HVAC installation impacts efficiency. So consider a builder who is paid for a 16 SEER air conditioner. That SEER rating, which is based on a standard lab test, is never going to change, but the installation quality will impact the on-site performance of the equipment. A properly installed system will get 16 SEER performance out of the equipment, whereas a poorly installed system will degrade that rated performance. The system is still rated 16 SEER, but the actual field performance might be closer to that of a 14 SEER air conditioner. So what does that mean? It means more energy and higher bills than what the builder had paid for. So that's obviously a bad thing. And that's not even the worst part, because HVAC installation also impacts capacity, meaning the amount of cooling or heating that the system can produce. In other words, that 3-ton system that they paid for should actually deliver 3 tons of cooling capacity rather than, say, 2.8 or 2.9 tons from a poorly installed system. Now, a small change in capacity might not seem like a big deal, but tell that to the homeowner or the HVAC contractor, when that homeowner calls on the hottest summer day, when you need every last bit of cooling power that was promised. So efficiency is great, but eliminating a comfort complaint or managing humidity better, that is priceless. It's because of these frequent installation issues that ANSI, RESNET, ACCA, ICC 310 was developed. Obviously, that is a mouthful, but there are lots of people that were interested in a standard that does what the standard does. And the standard has a few guiding principles. The first is to take a carrot rather than a stick approach. That means that homes are rewarded for doing the right thing as opposed to being penalized for doing the wrong thing. Second, it's important to reward incremental progress. So rather than taking a binary all or nothing approach, give homes partial credit for taking steps in the right direction. Third, rely upon procedures that are applicable to both raters and HVAC professionals. For raters, that means being able to do the tests even if they don't have an HVAC license. And for HVAC professionals, it means they could also do the test if they want to see for themselves how their systems are performing according to the standard. And finally, the test should provide value in and of themselves. So beyond any rewards for installing HVAC properly, you should learn something valuable about the system just by using these procedures. Now, at a conceptual level, the basic inspiration for the standard was the installation quality model for insulation that is used by RESNET standard 301 for energy ratings. And that is to say that grade 3 is the default. There's no assessment done to the HVAC system, and there's no penalty, but no credit. Grade 2 means that assessment has been completed and the system is doing okay, so you get partial credit. And grade 1 means you've done that assessment and the system is actually very well installed and designed, and you get full credit. So for raters who are on the call today, who are already doing energy ratings, this concept should be sort of familiar to you. And for those that are new, this kind of triage-based approach is very similar to what other partners in the Energy Star program have been experiencing for a while. So with that, let's get into the details of Standard 310. And let me walk you through a visual overview. The standard consists of 5 key tasks that are completed in sequence, and for each task, you have to meet a certain threshold in order to proceed to the next task. First up is a design review. If you're already certifying Energy Star homes on this call, then you're doing a design review today. So this is just kind of the latest and greatest iteration of that process. The second task is a total duct leakage test. And again, this is something that you'd already be doing for every Energy Star home. So something that might be familiar to some of you on the call. The third task is to measure the blower fan airflow, the total amount of air going through that HVAC system. The installation quality has a huge impact on airflow, and so it's a critical variable to measure. The fourth task is to measure the blower fan watt draw. So even if your airflow is good, the blower fan might be using a ton of energy to deliver that air. So we actually want to measure it to find out. And the fifth and final task is to assess refrigerant charge using a non-invasive procedure. And as we discussed, this is the other thing that is so often incorrect in systems. So let's get into a little bit more detail. Task 1, I said, is evaluating the design of the forced air system. And the first step is for the rater to collect design documentation for the dwelling that is being rated. For our Energy Star partners, this documentation is going to be slightly expanded from what you collect today, but it's not radically different. For example, you'll get a few more data points like internal gains, plus basic characteristics of all the HVAC systems in the dwelling. The second step is to review the documentation to make sure it's complete and to compare it to the dwelling. So key features have to fall within defined tolerances, and some of the examples are shown here. For example, the window area that's used in the HVAC design has to be relatively close to the actual window area in the rated home. Pretty logical. If the tolerances are met, then you can proceed to the next task. Otherwise, you stop here and you can't earn any points. So now we know, just for context here, we know that a design review along these lines is being done in about 100,000 homes per year just for the Energy Star program. So we think this task is quite achievable for the new construction industry. The next task is to evaluate the total duct leakage, and this is very straightforward. It's only about a page long in the standard. The procedure simply directs the rater to measure the total duct leakage according to RESNET standard 380, evaluate the results, and assign a grade. And the total leakage limits are shown here. And probably the most important thing to take away instead of the absolute numbers is that they're dependent on when the testing is done, so either rough-in or at final, and the number of returns in the system, either less than or greater than 3. You'll see that grade 1 aligns with the current Energy Star program requirements. So this is another task that we know is already being done successfully in about 100,000 new homes each year. Grade 2 is a bit more tolerant than that, and grade 3 is beyond that. If grade 1 or 2 is achieved, then you can proceed to the next task. Otherwise, again, you stop here and you can't earn any points. On to task 3, measuring the blower fan airflow. Now, this will be a new test for most, but not all of the raters. And the goal here is to measure the total airflow going through the blower fan. And there are 4 test methods you can choose from, what we call a flow hood, a flow grid, pressure matching, or the OEM static pressure table method. Each method has its pros and cons, but this gives the rater some flexibility to pick the method that works best for them. And a key point here is that you're just taking a single measurement in most homes of all the air that's going through the system. This is not a test where you have to measure the airflow out of each supply register and then add all those numbers up. That would actually be much more time intensive and less accurate for our purposes. So the result here is compared to the design airflow, and the closer you are to the design, the better. As we discussed, this has a big impact on the capacity and the efficiency of the HVAC system if the airflow is off. So the difference between the design and the field measured value is used to assign grade 1 or 2 or 3. The closer you are to the design, the better the grade. As long as you get grade 1 or 2, then you can proceed to the next task. Otherwise, you stop here. Now for today, I'm just going to talk in a little bit more detail about the 2 procedures out of those 4 options that I consider most likely to be used by raters. So of those 4 options, the first one I want to talk about is the flow hood method. And a flow hood is a device like the one you see on the right. Basically, this has a tent-like structure at the top to capture air going through a grill or a register. And then at the bottom, there's an airflow meter that measures the captured air that's going through that hood. So the basic procedure is to turn on the system, put the flow hood up against the return grill, and wait for it to stabilize. Now, there might be an additional step required at this point to account for back pressure. That means that the flow hood itself can actually impede the airflow and change the airflow a little bit. Some devices will do this automatically. Others require the user to take some manual steps. But once this reading has been taken, the resulting airflow is the total airflow of the HVAC system. If you know how much is going into that return grill, then you know how much is going through the HVAC system. So it's a pretty straightforward measurement. It's completely non-invasive. The second test method I want to talk about is using a flow grid. The first step is to measure the static pressure in the supply side of the HVAC system. And then you install the flow grid in the filter slot. If you're not familiar with the flow grid, it's basically a plate with holes of a known size that takes pressure measurements. It's shown on the right here. And knowing the pressures measured, it can calculate the airflow going through those holes. And so it's doing some calculations in the back end, but it's really pretty straightforward to use. So once the device is in the filter slot, you can measure the pressure going through it caused by the airflow of the HVAC system. Your manometer that's connected can convert that pressure to the airflow. And finally, you measure the static pressure again in the same location as step 1, and that allows you to correct the airflow. So the other 2 test methods available, the other 2 test methods available, I think, are going to be used less frequently by raters, and so I'm not covering those today. But if you want to see some informal instructional videos that are demonstrating all 4 of these test methods, then I really recommend the link here. It's a great resource. You can take a minute to jot it down, and you'll also get the slides, I think, after the webinar, hvacairflow.com. You can just click on Methods of HVAC System Airflow, and you'll find overviews, step-by-step videos, and procedural checklists. Now, just a caveat, this isn't a resource put together by us at EPA or by RESNET, the standard holder, but I think it's a really helpful resource to help jumpstart your understanding. It really makes a lot of this more visual. So consider watching that. Okay, so 3 tasks down and 2 to go. Next up is measuring and evaluating the blower fan watt draw. The blower fan watt draw is basically how much power the main air moving fan uses. It can actually use hundreds of watts, but in energy ratings today, it's not even measured. Now for this task, there are 3 procedures to choose from: a plug-in watt meter, a clamp-on watt meter, and using the house's utility meter. Using the measured airflow from the last task and the measured watt draw from this task, you can calculate how efficient that actual HVAC blower fan is. And this is used to assign a grade of 1, 2, or 3. The more efficient it is, the better the grade. Now, regardless of the grade, you can proceed to the next task. Today, I'm just going to run through the first 2 procedures, which I think are the most likely to be used by energy raters. The first procedure is using a plug-in watt meter. And a plug-in watt meter is a device you can plug into an electrical outlet and then plug another device into it to read its watt draw. So an example is shown here. So the actual procedure is fairly simple. You just plug the equipment with the blower fan, like a furnace, into the watt meter, and you plug the watt meter into the wall, and then turn on the equipment and read what the watt meter says. So pretty straightforward. Now there are some additional details in the standard, like what mode, meaning heating or cooling mode, you should set the equipment to. But that's pretty much it for this procedure. It's very straightforward. Obviously, you need to have a system that plugs in to an electrical outlet to use a plug-in watt meter. So that is the biggest drawback. You can't use this for all equipment. The next method is using a clamp-on watt meter. This is a meter that measures both current and voltage simultaneously, and it calculates the power that's being supplied to the blower fan. The procedure is pretty simple, and it's similar to the plug-in watt meter, but you need to know where to take the measurement, and you need to be trained to do this safely. It starts with turning on the equipment, and then you connect the clamp-on watt meter at one of two locations, either at a service disconnect or through an accessible and safe service panel. You're not connecting this at the main breaker panel, which is a little bit more risky because of the higher voltages and currents there. So once you've done that, you record the meter's reading. It's going to tell you what the watt draw is, and you're basically done. So that's it for task 4, 3 options for measuring the blower fan watt draw, and you're most likely to use that first or second procedure. So let's move on to the 5th and final task, evaluating the refrigerant charge. Here we have 2 methods for doing this. The first is what we call the non-invasive method, which measures the performance of the equipment during operation. And the second is the weigh-in verification method, which is more of a paperwork review. Now I want to go one layer deeper on these procedures since they'll be pretty new to most energy raters today. Let's discuss the non-invasive method first. By non-invasive, what we mean is that no gauges are being connected directly to the refrigerant system itself. So there's no pressure measurements where there's a potential risk of contaminating the refrigerant or changing the charge of the system. This is a really important feature of this method being non-invasive. Instead, the rater is using temperature, the temperature of the air and the temperature of the refrigerant lines to assess the charge. Now, this procedure is really intended to triage systems and separate those that are performing okay from those that are not performing okay. And for that reason, the method results in either grade 1, meaning the charge is okay, or grade 3, meaning it's not okay. For this particular task, there's no grade 2 performance like there is for the other tasks. Now, this method is not intended to replace the invasive procedures that are used by a contractor when charging a system like superheat or subcooling. Instead, it's providing a non-invasive method for the purpose of the energy rating. With that background, let me just run through what the procedure looks like step by step. First, the rater assesses key characteristics of the equipment, including its SEER rating and the manufacturer-specified superheat and subcooling values. The next step is to measure the outdoor air temperature and the return air temperature. So that's 2 temperature measurements. With just that information, the rater can calculate the target temperature for the suction line and the liquid line. So how cold are those lines supposed to be under these particular conditions? And finally, the rater can measure the actual line temperatures and compare them to those targets. If they're close enough, then the system is likely to be properly charged, and you'll get grade 1. Now, the weigh-in verification method is the second option you can use. It can be used year-round, and it actually has to be used under certain conditions, like when it's too hot or too cold outside, or for mini and multi-split systems. And this method is a bit more of a document review than a true performance test, but it's really the only method available for these certain circumstances. There are 2 main components to the test. First, the contractor provides the information that's shown on the left, like the weight of the refrigerant they added or removed when they were charging the system, the refrigerant line length and diameter, and a geotagged photo showing the amount of refrigerant that was added or removed. And the rater collects this information and then independently measures the refrigerant line length and diameter. Using this, they can determine how much refrigerant should have been added or removed to the system, and they compare that value to what the contractor reported to see if the difference falls within a specified tolerance. Finally, the rater reviews the geotagged photo the contractor provided, and they verify in their judgment that the location matches the location of the equipment. Okay, so I know that there are probably very few raters doing the refrigerant charge test today, and I think you'll want to give that a try a few times before deciding whether you can incorporate it into your daily inspections. However, we're pretty confident that many raters can do not just that, but all of these tasks. This graphic shows you a little bit more detailed workflow, standard 310. It reinforces what we've discussed today. As a rater, you'll be completing 5 tasks that are done in sequence, where each task must be successfully completed to move on to the next task. Again, those first two tasks are essentially being done today for every Energy Star home. So it's the last three tasks that will be new to most raters. We believe, again, that each of these is practical and achievable for a rater to incorporate into their ratings. Now, if you want to get started with HVAC grading, I'd recommend these three steps. First, download the standard, the link that's shown here. It's free. It'll tell you exactly what you need to do. Now, you don't necessarily need to read through it cover to cover and memorize it, but it's a really good reference to start to get acquainted with the procedures. Second, it's likely that as a rater, your home certification organization, or HCO, that you work under has training requirements before you can use standard 310. So just for an example, RESNET has 4 free modules online that they have their raters go through along with a field test before they can use standard 310. So there's probably some supplemental training that you'll be going through in addition to getting the standard. And number 3, give standard 310 on a try on a single house. See how it goes. And to help you go through that, just for the first test and then on an ongoing basis, I suggest downloading the ResNet data tool. It's an Excel spreadsheet that will guide you through each of the tasks, helping ensure that you collect the necessary data for the standard, and it'll also do the math to calculate your grades based on the inputs. So this is just 2 screenshots from these various tabs. The first screenshot on the left is from task 1. It's walking you through the design review. And the screenshot on the right is from task 2, evaluating the total duct leakage. It's making sure you meet your prerequisites per the standard, has you enter in your test results, and it calculates your grade. So this is a really helpful Excel-based tool that kind of makes the standard a little bit more real. Okay, let me pause there for a second. Brett, if you wanted to chime in with any questions so far before I talk about how this ties into Energy Star, I'd be happy to answer those questions. Looks like there's a lot of good chatter going on in the background too.
Yeah, no, there are a lot of great questions and conversation coming, and I wanted to kind of go back to one thing you mentioned and just kind of focus in on it real quick just to make sure I heard it right. But for the energy raters who are doing this, is there a requirement that they have some kind of HVAC license or testing? Did I hear that may not be true?
It's not true because they're not doing they're not handling refrigerant in any way, which would require an EPA certificate. So they're never touching the refrigerant system or changing the refrigerant charge in any ways. And most of the things that they're doing they're at least non-invasive options. For example, if you're using like the flow hood, you don't require any sort of holes to measure static pressure. You're just putting it up against the grill. So it's completely non-invasive. There are some cases where you need a static pressure hole in the supply plenum. Now, unlike some of the other methods that we've had in Energy Star in the past, it doesn't have to be a hole that's precisely located like in the equipment itself. It can be a ways down the supply plenum, completely away from equipment, so you're not running any sort of risk of changing the equipment itself. And if, as a rater, you can't put that hole in there because of really strict licensing requirements, like Florida has one of the more strict licensing requirements before you can even put a hole in ductwork, which is kind of wild to me. But before, if that's the case, then you would need to at least work with the contractor to leave you a hole so you can measure the static pressure yourself. Does that make sense?
Yeah. Yep. I think that does. And if someone wants to follow up, they can go for it.
Okay.
I think I'm delayed again. Can you hear me all right?
Yeah, I can hear you all right. I'll
Okay.
just turn on my camera while I'm answering questions too.
So there's some more really good technical questions come in. Maybe we can get to a couple of them here. You brought up the checklist, which I assume, depending on, some raters versus others, how much computer equipment they're bringing into the field, right? To fill out an Excel checklist versus maybe just filling something out on an app on their phone. But I guess the question here is, how is there a way to verify and capture this data? And so the question is like direct capture, pictures, like what is the thought? Or maybe that's going to be part of the Energy Star process here. But any thoughts on that?
So the standard is prescriptive in terms of where photographs are required, but mostly it's just with the contractor doing the weigh-in refrigerant charge and having to provide that geotagged photo to the rater. The rest is basically the rater recording the data themselves and documenting that. So if there is a quality assurance review by the home certification organization or a provider, for example, that they have that information on hand for them to do the quality assurance review for. So that's kind of the straightforward answer, is that they're taking down the information themselves and they're keeping a copy of that on record in case it's reviewed later. There are some tools coming onto market. I've seen some chatter about MeasureQuick in the chat, that might help facilitate raters collecting some of this data using connected tools, and then it just creates a more robust record. That's a little bit beyond the minimum standards requirements right now, but hey, that'd be great if we can move the industry more and more to those automated tools in the future.
Yeah. Can you elaborate on the fan watt draw grading, and that confirm they were saying, does grade 3 still pass?
So with so there's grade 1, 2, and 3, and it ranges, I think, at 0.58 watts per CFM down to 0.45 watts per CFM is like the nitty-gritty details in terms of grade 3, grade 2, and grade 1. So the more efficient you are, the better the grade is. Now, I think someone was probably looking at this. Let me go back, actually, one of my slides here. Someone may have been looking at this particular image where, regardless of which grade you get for blower fan and watt draw, you can move on to refrigerant charge. That's correct, because the quality of the blower fan grade will not impact the refrigerant charge. The reason we have restrictions on some of these other things, like you can't move on to do the blower fan airflow test unless you've done the design review, is that if your design is completely bogus, then how do you know what the right answer is for the airflow? Like if someone put in 400 CFM for the design airflow for a 3-ton system, and you measure 1200 because it's a 3-ton system, you're going to get a really wacky answer. So you need to make sure that your design review is correct before you proceed. Similarly, if your blower fan airflow is grade 3, meaning it's wildly off, then maybe measure the blower fan airflow and it's 400 CFM when it was supposed to be 1200. It's way low. Well, then your blower fan watt draw is also going to be really low, potentially, and so you might get a quirky answer. It might say, hey, this is a really efficient fan, but it's because you're hardly moving any air at all. So we want to make sure that your blower airflow is pretty close to the design before we let you move on to the watt draw segment.
Yeah, I'm glad you mentioned.
Yeah,
I'm glad you mentioned the design review, because we know that the HVAC design review is a requirement of the Energy Star submission. It's a requirement of Lead for Homes, minimum energy performance under energy and atmosphere. So I assume this program is not meant to replace that design review. I assume that it sounds like that design review is still helping, or still required, and it's giving you clues on what you should be finding. Am I saying that correctly?
Yeah, we have some standardized design reports that are consistent with the requirements of Standard 310. Those templates have been built into some of the major design programs that HVAC designers use, like RightSoft. So when the designer finishes, they can print out that design report for Standard 310. And then, the rater is doing the standardized review that compares that design report to the actual rated home.
Now, what about the commissioning report? I know that, technically speaking, that's supposed to be required for Energy Star certification.
Yeah. Why don't we hold that
it.
question until I get to the next part, because that actually talks a little bit how that gets into how it
okay, true. Yeah, that's we're getting ahead. That's right.
That's fine.
I appreciate that. Yeah, I'll bring that up later. Let's there are some other really great questions and conversations coming in, but why don't we just move into the Energy Star portion, and then we'll get to those.
Yeah, and just to follow up on one of the questions that you raised regarding data collection, I just want to shout out to the response that Connor provided regarding BSI. That's another home certification organization. They actually have, they use HouseRater, and they collect all the data through that system, including photographs. So for example, they would have a higher bar in terms of photograph requirements than RESNET right now in terms of the data collection. So those data collection requirements are being set by the oversight organization themselves. All right, let me go hop off back here. Get back to my slides. Okay. So now you know a little bit more about what HVAC rating is. And so I want to discuss how HVAC rating integrates into, and we think improves, the Energy Star program. But first, let me say that one reason you might and many others might care about Energy Star more this year than they ever have before is the newly defined 45L tax credit for efficient new homes. Perhaps you've heard something about this. This is a really big change from the old version of 45L. And so I wanted to touch on it in case you've heard maybe a little bit about it, but don't know the details. For homes and dwelling units that are acquired on or after January 1st of this year, the base level federal tax credit is specifically tied to meeting Energy Star program requirements for single family, manufactured, and multifamily homes. And specifically for single family new homes, which we're sort of focused on today, $2,500 tax credit is available. For homes that are acquired from January 1st of this year through the end of 2024, generally Energy Star single family national version 3.1 is required. And then from January of 2025 through the end of 2032, national version 3.2 is required to get the tax credit. Now, one important caveat is that we're still awaiting guidance from the IRS on a handful of issues, because it's actually the IRS implementing the tax credit, not EPA. And that includes things like how do the regional requirements of our program overlay with the national requirements. There's still some dust to settle around this, but the basic premise is that you can now be eligible for the federal tax credit by getting the home certified to Energy Star, and that's a big deal. Now, a larger tax credit is available for homes that are certified to DOE's Zero Energy Ready Homes program, which you mentioned, Brett. That requires Energy Star certification as a prerequisite. And this last thing is also a big deal. The tax credit has been extended through 2032. So there's actually a long runway for builders to kind of get their feet under them and decide if this makes sense to pursue. Okay, so with that context, let me get back to the topic at hand. How does HVAC rating fit into the Energy Star program? Well, we now have two tracks to choose from to satisfy the HVAC design and installation requirements in the Energy Star program. In fact, it's a bit of a choose your own adventure. In this journey, you have these two options. Track A is the shiny new track called HVAC rating. So if you follow this track, then all of your HVAC design and installation requirements are built on standard 310. Or you can choose track B. This is well-worn and familiar. We're calling it the HVAC credential track, but this is the track that our partners were on for the last 10 years. So under this track, you rely upon the Energy Star HVAC design report instead of the 310 design report. You rely on a credentialed HVAC contractor who completes the HVAC commissioning checklist. So for each Energy Star home you certify, you can choose track A or track B. That said, we think that track A is really the future of our program. And so over time, we expect more and more of our partners to use it and to eventually sunset track B. So why do we say that track A is the future? Well, we think it improves the Energy Star program in a few key ways. Number one, it finally rewards properly installed HVAC systems with ERI points. And you can choose those points for a regular you can use those points for a regular energy rating or to meet the Energy Star ERI target, which is now the basis for that federal tax credit. So you were referring to this as well, Brett. You could use this to help meet your performance target in LEED. You could do it for a standard energy rating. You could use it for Energy Star. It's multifaceted. So how many points are possible? Well, this is a very rough estimate because every home is going to be a little bit different. But for a home that say is efficient as Energy Star version 3.1, for an air conditioner, you can get probably about a point in a cold climate, a point or two in a mixed climate, and 2 to 3 points in a warm climate, and probably 3 to 4 points in a hot climate. Now, if you're in Michigan, maybe that doesn't seem too impressive because it's a cold climate, you can only get a point, but it's a very different answer for heat pumps. They're running basically year round, not just, in cooling mode. And so with the longer runtime, you can get about 3 to 4 points across the board. Now, the results are going to vary by home, and you only get all these points if you perfectly install the HVAC system, but this gives you a rough ballpark of what's out there. You might see a little bit higher, a little bit lower, depending on the case. So this is a really big change from before, where the only thing that was really going into your credit and the energy rating was the rated efficiency, not the kind of installed performance of the system. Number two, using the HVAC grading track, this track A, the contractor no longer needs to be credentialed, nor do they have to complete the HVAC commissioning checklist. And one persistent challenge we've had in the Energy Star program since the launch of version 3 about 10 years ago is that in smaller markets where there are fewer Energy Star homes being certified, it's been more difficult to find a credentialed contractor. And that's partially because of the cost structure. There's a flat annual fee associated with becoming credentialed. That's typically around about $600, give or take. And if you're working on like 25 or more Energy Star homes per year, that becomes a pretty low overhead. But if you're just doing 1 or 2 homes a year, you're just getting started as a contractor, that's a pretty big lift. Now the cost of the credential no longer needs to be an excuse for not certifying a home nor completing the checklist, which we sometimes hear contractors will charge up to $100 just to fill out that paperwork. You get out of those requirements because it's now the rater who can assess the installation quality themselves for the purpose of the rating and for our program. And last but definitely not least, HVAC rating integrates most Energy Star HVAC requirements into a standard energy rating. That's a big deal. In fact, almost all of Energy Star just becomes an energy rating with above code performance and certain efficiency features locked in. So you're going to hit a performance target, you're going to use grade 1 installation, you're going to aim for grade 1 or 2 HVAC system installation, you're going to have tight ducts and minimum insulation and window performance. And if you're doing that, which is basically just a good rating, you're 80% of the way towards doing Energy Star. Without even picking up our program requirements, probably what you'd consider to be good energy rating is getting you most of the way to certification. So what are we doing on top of good energy rating with certain features locked in? Well, on top of that efficiency, we're adding a handful of extra features. We're adding 2 comfort features. The first is a complete thermal enclosure system. Basically, it's the thermal bypass checklist, which we know from version 2 of our program, lots of builders can do. And essentially all of this has been integrated into code as well. So there's really no excuse not to be paying attention to these details that make a complete thermal enclosure system. The second comfort feature is bedrooms that are comfort balanced. Homeowners spend more time in their bedroom than almost any other room. And when the bedroom doors are closed, as they often are, air can become trapped. It's not enough to supply conditioned air into each bedroom. The air also needs a pathway back to the HVAC return side. There's a variety of ways to create a return air pathway, such as a transfer grill or jump ducts or dedicated returns, or not quite as recommended, but maybe something as simple as undercut doors. But this is a mandatory feature in the Energy Star program because it really helps enhance the comfort of the home. So those are the first 2 features we add on. We're adding 4 air quality features, which are more valuable now than ever before. Because we're building a high performance home, we're going to build it tight and ventilate it right. And that means we'll add a whole house fresh air system to deliver a consistent amount of fresh air into the home instead of relying on the whims of Mother Nature. So there's a variety of options to do this. It could be something as simple as a bath fan with a special controller, to a motorized damper on the return side of the HVAC system, all the way up to something like an energy recovery ventilator. But the point here is the system is going to have control over when the air enters the home. And this is now required by nearly half of all states just by code anyways. But even where it's not required, it's really something that a builder should be doing regardless for the health and comfort of their home buyers. That was bringing fresh air in. The other half of the air quality equation is taking the bad air out. And so we'll add vented exhaust fans in the kitchen and the full baths. Maybe you already know that cooking creates a number of contaminants like formaldehyde and ultrafine particles, fine particulate matter, lots of water vapor. You're really kicking up a lot of stuff into the air. And there's a reason, for example, that commercial kitchens have enormous range hoods with huge rooftop fans. And the home, range hoods that are installed in recirculation mode, sometimes they're just blowing those contaminants back in your face. So it might look good, but it's really not doing a lot. And that's why we're requiring those range hoods to be installed with ducts that go to the outdoors to get those contaminants completely out of the home. The third air quality feature is that every Energy Star home and apartment includes a MERV 6 or better filter in the heating and cooling system. That's going to remove contaminants from the air as it passes through. So pretty straightforward. And the last air quality feature is combustion safety. That comes in a few different flavors. You could use power vented or direct vent appliances, which a lot of builders are using today anyways. You could do combustion safety testing, or you could keep the combustion appliances outside the home's pressure boundary. Another great option is just to use electric appliances, and that avoids the combustion issues altogether. Whatever strategy you choose, this is really just a question of due diligence to keep your home buyers safe. And the last feature is the durability feature, the water management system. That basically means proper flashing to keep bulk moisture draining away from your home. In other words, don't tuck your raincoat into your underwear. That's a bad idea. Now, originally, years ago, this was a builder checklist, but at this point, we've completely eliminated the checklist and paperwork collection. It's just a list of details that the builder has to implement. And almost all of this is baked into code. So it's not really something that, case where we're asking for a lot more than what builders should already be doing. We just know it's super important for high performance homes because leaks and other moisture issues can be so damaging. And in fact, a lot of our partners go above and beyond these requirements already, for example, by having third-party assessments of their water management details. So that is it. You can fit the Energy Star features on one page once you've integrated the HVAC rating into the standard energy rating. We're doing a good energy rating, it's done the right way, and we're adding 2 comfort features, 4 air quality features, and a set of durability details. And just ask yourself, which of these features would you tell your client to leave out? Which would you leave out of your own home? Hopefully none. And just how hard and expensive would it be to add these features after the time of construction? In short, we think that HVAC grading is really transforming the Energy Star program. It creates a much more streamlined set of requirements that we think any builder can step up to. In short, we think that Standard 310 is a good news story for everyone. For builders, it can help improve their energy ratings. It can help meet the tax credit, and it can improve comfort and durability, which is a really big deal for builders, obviously. On top of that, raters have a valuable new service to offer, not just for Energy Star builders, for this little niche that we're in, but for any builder out there doing an energy rating. Utility programs can incentivize and claim credit for proper installation right within an energy rating program. They don't have to do separate savings calculations like they did before. And we think there's also an incentive for HVAC manufacturers to, they now have a reason to add features that make installation easier to do and to verify. And last but not least, in my mind, of course, for Energy Star, it means that the stuff that our builders have been focused on doing right for the last 10 years finally get credit in an energy rating. That means really a huge simplification for our program and potentially lower cost of certification. So that's a big deal too. And that's what I have for you today. So let me turn my camera back on and I'll answer any Q&A that we have.
Yeah, Dean, let's start getting into some of those questions. And before we get into those questions,
Sure.
just a couple things. I think I might be on a delay here. But just as a reminder, you all can rewatch this session, share it online, post it, go to our YouTube channel, click subscribe. Yes, the session is being recorded, and you'll get an instant update once we have it available. For those of you watching this in the future, not right now, but on demand, make sure to head over to our CEU quiz platform, get an 80% passing rate. You'll receive your certificate of compliance. For those of you here today and have been here for the entire CEU approved session, check your spam for certs at gutenbergcerts.com, mark it as safe. You will receive your certificate for attending. And as we're seeing some of those questions come in, we're going to get to them here in a second. Again, we always have to say a huge thanks to our board of directors, our volunteers, our nearly 300 members. We're almost there. I hope you can help us get there. And some of our top tier sponsors who are especially out there trying to help you meet these standards, such as Mitsubishi and Rheem with their air source heat pump products to achieve these sustainability goals. So, Dean, some of the questions that that were coming in, and a lot of great technical conversation going on. So I appreciate everyone who's kind of behind the scenes navigating that and helping out. But one that kind of jumped out to me was the and I've kind of heard this said in before, where some of these systems, like mini split systems, they kind of get a pass. In part because, partially because even air source heat pump systems and some air conditionings, they come pre-charged in the factory. And then even some of these mini split systems, there's just not standards in place to test them. So can you speak to either how Energy Star is planning to handle these, or what the future is going to look like for pre-charged and mini splits real quick?
Yeah, it really, for mini splits, one common feature of them, which is really what standard 310 keys into, is that they're ductless, or they have very short duct runs. And the duct installation is one of the key installation issues that can occur for a typical system, because that duct system changes the static pressure, that changes the airflow. So in standard 310, it recognizes if you have any system, mini split or otherwise, that has less than 10 feet of ductwork, then you're going to automatically get a pass on the duct leakage test, because it's unlikely to have a significant impact on performance. you get a pass on the airflow test. You get automatically assigned grade 1 because there are just fewer things that will change, there are fewer things during the installation process that will change the airflow from the design intent. So you get grade 1 airflow, and you actually get grade 1 blower fan watt draw, because again, the reason we want to test the blower fan watt draw in part is it might be working really hard to overcome high static pressure in a duct system that's been installed. So you actually get grade 1 basically up through the refrigerant charge test. You still have to do the refrigerant charge test. You still have to do the design review at the front end to make sure your design intent is being satisfied. And the back end, the refrigerant charge, you still want to make sure that it's properly charged, and you're going to be using the weigh-in method to make sure that whatever the manufacturer says, should be added because it's a longer line length, for example, the contractor is actually done and the rater is doing the math check to verify that. So it does really streamline things for them. And the good news is that, properly installed mini split system that's ductless is going to get just as many points as a ducted, air source heat pump. And so your point potential is the same. It's less work to kind of demonstrate the proper installation for that ductless system.
Yeah, well, and that's always been one of the cruxes we've seen out there in the field is duct testing can certainly be a problem, and it's expensive to fix. So some people are like, how do we eliminate this? Well, I'm like, well, if you don't have ducts, you don't have to test a duct system or a shorter ductless mini split run. Now, what about ground source heat pumps, otherwise known as geothermal? There's a 30% tax credit under the Inflation Reduction Act that is back. A lot of people don't realize that it's back. So there's, of course, more interest in that now. How are those systems getting tested, or what's the intention here? So,
that wasn't entirely the focus of the first edition of Standard 310. So it's really focused on air source heat pumps. There's some language that's in there that could be leveraged in future editions of 310, but there would need to be some clarifications in the standard. And so right now, at least RESNET, for example, for HERS ratings that are done as part of RESNET's home certification organization, they're saying only use 310 for air source heat pumps for the time being. And that might be something that we revisit in the future. And so the way that we structured basically HVAC grading is you start off with no penalty. It's just extra point potential. So you wouldn't necessarily be available to get those points today, but you're not going to be penalized for having a ground source heat pump either. And, you tend to get a lot of credit for ground source heat pumps because of higher efficiency, higher rated efficiency, for example. So there are lots of reasons to use ground source heat pumps if you want to. Don't let the grading standard hold you back.
Okay. So basically, effectively, you can't use the 310 standard just yet for it, but you're already probably getting rewarded for it. It's more efficient. And I know that some of these, and for those who are just genuinely concerned about proper commissioning, which is another concern, right?
Sure.
I know some of these ground source heat pump companies are coming out with methods to ensure proper commissioning. I assume you want to make sure that's done correctly. So
yeah, for sure. And I think just tangentially, that's a good point that, I want to be as clear as possible. 310 is tools that a rater can use to assess the performance for the purpose of an energy rating. I said that in various ways during the presentation. So there are lots of things for an air source heat pump, for ground source heat pump, for any mechanical system basically that you want to commission. The contractor still plays an important role in making sure it's installed properly, because just like a duct system, if the contractor doesn't install the duct system tightly, then when the rater measures it, it's going to be leaky. So the rater is playing a key role, but is still relying on the contractor to do the right thing when they're putting the system in.
Yeah. So, I'm trying to look at this from like the energy rater's perspective. On one end, they're already out there doing a lot of this stuff. They have a lot of this equipment. They're testing ventilation. They're testing HVAC. They're signing off saying the HVAC system is working. But on the other hand, this is, of course, maybe more equipment that they didn't have. And in some cases, maybe more liability that they didn't have. And so in the event that raters are concerned about, especially on the liability side, what would you say to them? Is there an opportunity for them to maybe collaborate more with the HVAC? So it's still the HVAC doing it, but they're right there. Like, what are your thoughts there?
Yeah, I think, raters have to collaborate with contractors today just to get, expectations set for the HVAC commissioning checklist. So you're always going to have to collaborate with the contractor. I think what this offers is a much more robust feedback loop to the contractor and to the builder, frankly, about how the system is performing. And so I was mentioning duct leakage, for example, prior to duct leakage testing, which is now standard place, an installer is always going to say, hey, I did a great job installing this duct system. And in a lot of cases they have, but in some cases they haven't. Until you actually measure that as a rater, as the third-party assessor, you don't really know what the answer is. And so we've heard, I think this is a really insightful case study. We have one builder in the Mid-Atlantic who just started doing HVAC rating on every single one of their homes this year. So they've kind of ramped up to support this, and they're not doing it for the HERS points or ERI points. They're doing it because it's creating the feedback loop that they need to know. They actually do all their HVAC designs in-house. And so now they're saying, hey, this particular contractor seems to be getting grade 3, while other contractors in the same market are getting grade 1 or 2. What's different? Or we have a new HVAC design for this new house design. It keeps failing. What's wrong with our design? Is it an undersized return that's restricting airflow, so we're getting grade 3 all the time? So it's creating that feedback loop that just wasn't there before with the HVAC commissioning checklist, where it's a piece of paper that the rater couldn't really assess. They might see something that's a little quirky on it, but really their job ends with looking at the paperwork and moving on. So I think it's just a much more robust feedback loop. So this is a long answer, but I think it's an important topic. So I'm kind of going on a little bit. For a rater, again, because this can be used for any energy rating, they could step into this piecemeal. Like they may feel only comfortable doing the HVAC airflow test, buying the equipment for that, and they're able to get some partial credit for the builder that couldn't be gotten before, and they can create a feedback loop just for the airflow. Maybe that's all they're comfortable with to begin with, and that's fine. And then they could step into the watt draw second, make an investment on that, and then finally get to refrigerant charge. Now, if you're doing track A for Energy Star, you kind of have to jump to doing all that at once. But for someone doing an energy rating, then that would be a way for them to step into that. I think it's going to take time, but I think they can take it in bite-sized chunks.
Yeah. Now, I'm glad you brought up the HVAC commissioning checklist, because I may have, I know I had a question about it earlier, and then I was listening to see if I heard about it again, may have missed it. Can you just remind me again, is this taking place of that paperwork?
It is. Yeah. Okay. So our quality assurance process before was the contractor basically self-reporting the commissioning that they were doing. And this is basically the rater saying, it would be the equivalent of, again, the duct installer writing down on a piece of paper, my ducts are tight. Don't check them. You don't need to check them because they're tight. And the rater saying, well, I've collected your piece of paper, but let me actually do this test and see how it's performing. And so we think it's a better approach. And it does replace that paperwork, which honestly was a burden for contractors. They didn't love the idea of having to fill out the paperwork and finding the rater to turn it over. And so that was a pain point for the kind of workflow in a lot of cases. So, this is a kind of cleaner approach where everything is in the rater's world and they can measure it themselves.
Well, that's good to hear, because a lot of times raters are spending time just chasing a signature on a document.
Now that no one enjoys.
Now it's like we can have real tangible verification methods and real data. And I think it's just a big win for everybody. So it's very exciting to see. I know on lead projects, that's often, it's like, what's the last piece of paperwork missing? Oh, it's the HVAC commissioning report. They got to come back out and commission the system and wrote down what they found. So it certainly, I think from our perspective, looks a lot more enticing, especially with the increased points. So now, Dean, new construction is expensive. Land is running out. We have millions and millions of existing homes and multifamily buildings that need to be repaired, refurbished, refixed, and improved. I know Energy Star and LEED have always been just kind of like going back and forth and trying to figure out what we do with all these existing homes to measure it, right? And, I know LEED has recently found ways to say, look, if you can achieve a HERS index rating or equivalent ERI of 80, and you can verify a couple things, we don't really need you to like tear apart the walls in the commissioning or the HVAC system. So they're trying to make it easy. I'm not quite clear if Energy Star is doing likewise or not. And there's also home performance with Energy Star, so I'm not even sure that's made for existing homes, but I'm not sure where that comes into play with all this. But my question really is here, like, okay, we've got an existing home project, and, I assume if they're going to be making an informed decision to change out the HVAC system, it might be because they see all of these tests are coming back really bad, right? So where can this come into play for those millions of homes that we need to get renovated? What benefit can it be? Can it play a role?
Yeah, so I do mostly have my new construction hat on, so
Yeah.
I don't have as maybe a
Mhm.
prepared response on the
Mm.
existing home side because I don't
Yeah.
spend as much time thinking about that. But there are protocols and certifications in place
Mm.
for properly verifying installation of new equipment that's going into an existing home. Energy Star has one right now, but it's doesn't have a lot of traction right now. ACCA has similar certification programs, and they're partnering with EPA to do some of that work in terms of recognizing proper installations as well. I think Measure Quick also has some tools that help support demonstrating the proper installation of new equipment in existing homes. And a lot of this logic overlaps. Like you want to make sure, as you're kind of alluding to, Brett, like you want to make sure the airflow is right. You want to make sure the refrigerant charge is right and the water draw is not too high. So there's a lot of
Mm.
ways that you can extend this. It's just that, you know, it's primarily been geared, this standard itself has been primarily geared towards application to the new construction market. So that's kind of where I'm spending most of my time kind of getting it stood up. And we kind of say like fixing the new construction industry is the easy part in the grand scheme of things.
Right.
We got to at least get that right before we can worry about all the existing homes. So that has to do a little bit with the insulation quality of HVAC systems and new and existing homes. There are other EPA initiatives that are also addressing existing home efficiency overall that's different than Energy Star single family new homes.
Sure. Fair enough. Well, I appreciate you at least taking a
Sure.
shot
It's
at
an
trying to.
important area.
Yeah. I know lots of people show up with questions on existing housing. So, Dean, I really appreciate your time, and EPA Energy Star for coming out again and talking to us and putting these awesome programs together to help people build better homes. Can you just remind everybody again where they can go to learn more or get more information?
Yeah. So I think these top 3 links on the screen that you can see are the places I recommend. So energystar.gov/new homes requirements is the main landing page for the technical requirements of the single family program. If you're interested in multifamily, then energystar.gov/MFNC for multifamily new construction. And then the best place to start with questions is Energy Star Homes at energystar.gov. They'll get routed to the right person who can answer the question most efficiently. And if you do want to reach out to me directly, you can see my email address at the bottom there, gamble.dean@epa.gov. I know some people asked questions that we didn't get to today, so feel free to follow up with me if you need an answer, and I can try to help you out.
All right. Well, thank you so much, Dean. I appreciate your time. Take care, everyone. We'll catch you next week to continue conversations on energy efficiency. So take care.
Sounds good.
Goodbye.
Thanks. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.